Hello, hello. Happy whatever day you're watching me, and welcome to our next lesson. Yesterday we learned about substitution when solving a system of equations. It involved quite a bit, substituting one equation into the other, and then we had to get our x's to one side, solve for x, and then use our x to find our y value. Now what we're doing today is very, very similar. Regards to this part is the exact same, where we plug one equation into the other, substitute it in. We will still be solving for our variable. We will still be plugging that back in to find our missing variable and then writing our answer as a solution. It's just this math here in the middle is going to be a little bit different because we have a little bit of a different setup for our equations. You can see here that both of my equations are solved for y equals and y equals. For today's lesson, what we're looking at is we have one that has y equals and then one that doesn't. And so what that ends up doing is changing that middle math a little bit. So a few things before we get started. A reminder that we use substitution to solve a system of equations for x and y. Substitution is easy to use when we have x or y already by itself for one of our equations. And we use this so that way we can solve for one variable at a time. We first solve for x, and then we solve for y. And we do this because it's impossible to solve an equation that has two variables. We can only solve it if there is one. So we substitute so we can focus on one at a time. A few things you need to remember for this lesson are combining like terms. So that means we combine coefficients with the same variable. So here we have a 3x and then a negative x. So we can combine those because they both have an x. So we have 3x minus an x to get us a total of 2 x's plus 14, and that equaled 114. And then from there you would solve for x. But the key here is how to combine like terms. And then the other thing you need to know for today is how to distribute. So taking this thing on the outside, this number on the outside, bringing it to both things inside by multiplying. 2 times 5x, 2 times 7. 2 times 5x is 10x, 2 times 7 is 14. Knowing how to do both of those are super important for today. And if you need help with that, just let me know. But with that being said, let's go ahead and get started with one of these problems. So again, just like yesterday, step one, when we're solving a system of equations using substitution, or if I just said solve a system of equations and gave you this, you would say, oh, I have a y by itself, so I'm going to use substitution. I know that y equals this whole thing right here, so I can plug that in for y. So I'm going to write negative 3x plus 40, and then I'm going to write up the rest of our equation, plus 5x, or actually, sorry, I'm going to do black. I don't like that. Plus 5x, and this equals 60. Okay? Now we have an equation with only x. Now we can figure out what our x is for our system. At what x value are my equations equal? So we have to combine like terms here. You can see how we have an x over here and an x over here. Now the difference from yesterday is that these x's are on the same side of my equal sign. So we can simply combine them. So I have a negative 3x and a positive 5x. 5 minus 3 is going to give me 2x. And then we have that plus 40, and that equals 60. We have 2x plus 40 equals 60. To solve for x and get x by itself, we move the addition first by subtracting. And we get 2x equals 20. From there we have 2 times x, so we get rid of that by dividing by 2 and dividing by 2, and we get x equals 10. Okay, so now we have our x. Again though, this is a system of equations. we're looking for the point, the ordered pair, where my equations would cross, or where they would be the same at the same point at the same time. Well, if I'm looking for the point at which they cross, I need both an x and a y. So after we've solved for x, we need to use it to find our y value. Again, we did this in our previous lesson. I'm going to use a different color to show this. So again, I mentioned this yesterday. Plug your 10 back into either of these equations. It's easier usually to plug it into the one that's already solved for y. So for this one, I would write y equals negative 3x plus 40. Again, we have two variables in this equation, so I need to find two numbers before I can be done with the problem. So x equals 10, we're going to plug that in now, and we get negative 3 times 10 plus 40. Now we solve this in order of PEMDAS, order of operations. Multiplication comes first. And then from here, y equals 10. And then to end it, you write it as an ordered pair, because again, when we solve a system in your head, when you think solve a system, I want you to think, oh, that's the point at which they intersect. A point on a graph is an x and a y written like this. So we're going to write our x value and then our y value. And there we go. Sorry, I have something in my eye. If you need to get this down and you're not finished yet, go ahead and pause me. Otherwise, I'm going to keep on moving. But if you need to get it down, just rewind and pause. All right, next one. Again, it's the same kind of problem. I just want to model another one before I release you to try your independent practice. Alrighty. I'm going to use the purple again. Okay, so solve the system. I see y by itself, so that tells me, okay, I'm going to use substitution because I could plug this in. So I'm going to take this and plug it where y is. So then when I write this down, we have 3x, ooh, come on, plus 2, and now we plugged in that expression, 6x minus 1. Remember to put it in parentheses to show that this whole thing is being multiplied by 2. And this equals, ooh, I don't want that. And this equals 43. Okay, now we solve for x. Hopefully, from the beginning of when I mentioned these two things are important for today, as soon as you see a number outside of a set of parentheses, a light bulb should go off in your head that says, oh, I need to distribute. I need to take this number outside and multiply it by both things inside. So I'm going to take this 2 here and go 2 times 6x and 2 times negative 1. So we end up with 3x plus 2 times 6x is 12x. Ooh, I don't like how I wrote that. And then we have a minus sign. 2 times 1 is 2. Okay, now we've distributed. Now there's something else we can do. We have 3x plus 12x minus 2 equals 43. What do you think we can do here? See if you can figure it out and write down the next step. Hopefully you're thinking, oh, I can combine like terms. You would be right. We have x's, two different x's, on the same side of my equal sign, so we can combine these together. We have a 3x, and we have a positive 12x. So when we combine those, we're going to get 15x. 12 plus 3 is 15. We got that minus 2, and that all equals 43. Okay, from here, solve for x. We have 15x minus 2 equals 43. Go ahead and pause me now and see if you can get x by itself. Unpause me when you're ready or if you can't figure it out. Okay, so we have 15x minus 2. Remember, we get rid of addition and subtraction first. So we're going to add 2 to both sides. And we get 15x equals 45. We have 15 times x. We get rid of a times by divide. And then 45 divided by 15 is 3. Okay? And then again, we aren't done. In our system, we have two variables. We have x and y. I've solved for x, but I still need to solve for y. We are not finished until we know what both variables are. So we're going to use the variable in step 2 that we've found to solve for the other variable. So now I know that x is 3, so I can plug that back into this first equation here and find what y equals. Again, we want to use this first equation because it's solved for y, so it's going to be a lot easier. Yesterday, it didn't matter what equation you plugged it into because both of them looked like this. Both of them, oop, you cannot see that, because both of them were y equals and y equals. So with that, it didn't matter. But for today's lesson, because only one equation is solved for y, that's the equation we want to use. So 6x minus 1, x is 3, so we're going to take that and plug it in. And we get y equals 17. We have our x value, we have our y value, therefore I am now done. And then again, we write these values as an ordered pair to show this is the point that makes both equations true. This is the point where if you graph these two lines, they would cross. All right, again, if you need to get this down, just pause me to finish it up. But I'm going to keep on moving. Again, pause me if you need to. For your independent practice, you have 6 problems. The first 3 are similar to what we just did. Remember, x, just imagine there's a 1 in front of it. Now, the one I want to talk about are these last 3. So number 4 looks like x equals. The only difference with this one, you have to plug the expression in for x and then solve for y. So this is what x equals. So you would take this and plug it in for x instead of y. So then you would solve for y and then get y and then plug it back in to solve for x. So we're just kind of flipping it around here. You're solving for y first. And that same thing happens with number 5. You're going to take, this is x equals this, so you're going to plug this in for x. And then solve for y first. And then number 6, just your equation is on the bottom. This is the one that's solved for y. So it just flips up. And you would plug it in for y in the top. Nothing too crazy. I want you to go ahead and try all of these. You will have the answer key. So once you complete it, you can check and see if you did it right. But once you finish, let me know. And also attempt your mastery check, please. And then send me a message when you finish. If you do come up with any questions or you're confused on one of those problems, just let me know and we can have a chat and I can help you out. All right, have a great day.